Howdy. I wanted to share some observations and also show some facts about why I think these observations are at least interesting. So now we have Scandinavia here, Norway, Sweden, Finland. Here is marked the plasma rock site and the Outokumpu copper mine. And this might be a positive surface conductivity anomaly, and blue ones are negative. Or north or south, or however you want to put it. For those who don't know what I mean with the plasma rocks, these are the plasma rocks. This has been in the Thunderbolts video. There are some more pictures from the plasma rocks. I have a playlist about the plasma rocks. There are many, many more pictures about this site, which is really, really interesting. Actually, maybe you like these kind of pictures. We have craters and tetrahedrons and everything electric universe people like, and a crater. This is a crater made by a lightning bolt. So now, actually, I was talking about weather. Let's go back to this map, what we had before, this one. I made some videos about recently that we had this convergence line here. And we had convergence zone lightning. And I noticed that we have in Sweden, I'm not exactly sure, is it exact this location? But this is what I try to figure out now. But first, before we go to windy, I wanted to show you how it looks from underneath, from the plasma rock site. And I found this map because I noticed, since living here in this town, that there's almost no thunderstorms here, which sucks. I like thunderstorms. And I was thinking there must be a reason why we don't have any thunderstorms here, or really rare. And after some research, I found this map and I figured out that yes, this might be the reason, because of the surface conductive anomaly. It repels bad weather because it's positively charged. This is how I see things. It's probably too easy, or probably it is so because it's so simple. I don't know. This is what I'm trying to figure out, how much this surface conductivity anomaly influences weather patterns here. But now, let's go first over to windy. This is visible cloud layer over Europe. And I think this looks really, really, really interesting. Just here is plunging in cold air. Here is going up hot air. The warm air should go there to bring us summer and spring. But it doesn't. Instead, we get again, we had it already a few weeks ago, this spinning low pressure system over Europe, Scandinavia, sorry. And I am here. So maybe we can zoom in a bit and I can show you the plasma rock site. The crater, what I showed you just before, is here. Maybe I should show you a better picture of the crater. This is what I'm talking about. The picture what you saw before in the article was black and white because it was easier somehow to compare between those two. What is not that well visible is how round this is. It's really round, it's molten. And that's the epicenter of the lightning discharge. It looks like the Ricard structure in a way. This is from the other side. Down here we have this really round feature. This is this round wedge what I try to explain. Even though it looks rocked, it's quite smooth. And it's really hard to take somehow a proper picture to show it how it really looks. But you can see this brush fits underneath. That's actually the same picture, a little bit enhanced. But this is the crater I was talking about. Anyway, let's go back to Windy. So this is the place where the crater is. Now, this is approximately the spot you want to watch. And if we watch now 12 hours, it's approximately here somewhere. Let's try to make a better mark. Approximately. And we have been in this convergence zone for quite a few days. And first it was like that, and now it's changing, at least to 90 degrees. And there is no clouds or whatsoever. And this is also visible from the ground, because I wanted to show you that how it looks, what I mean, being surrounded by clouds, which I think is in a way an extreme weather situation. So this is taken at noon, approximately, which means the sun is over my head, more or less. So if there's any cloud in between me and the sun, it's above me. If it's not, it is not above me. So there's clouds on the horizon. Here we have the sun, nothing in front of the sun. Clouds all around. We have filamentary structures up high in the sky. They are really nice. And you can see all the time that. Let's go to the beginning again. I just wanted to point out that here, all the way around, are clouds. Some are coming closer, obviously. Yeah, the weather is gonna change. But there's clouds around the town, but not over the town. And I think the plasma rock site is one of the reasons why we don't have clouds. Because of the positively charged potential of the rocks and the whole environment through to electrical discharge events. In the past, this is I thought I probably could enhance and see is there anything more contrast, because I thought they look really neat. We can see plasma. It behaves like plasma. Filamentary structures. They are like 90 degrees in a way. And it's due to the convergence, because if we go back to windy, uh-huh, no, double layer, and here in between there is going to be created energy. And if we go over the weather rather, now I remember that I was supposed to talk about Swedish stuff, because we have also in Sweden convergence lightning, convergence zone lightning going on at the moment. And obviously it is at the same height as Helsinki. So we might go back to the map. The map. So the lightning is happening here at the moment, because Helsinki is down here and we want to stay on the same latitude. So it doesn't have anything to do, at least it seems at the moment, with this. Let's see how this region works. There we have extreme drought. It's totally red on the drought monitor map, which is not displayable with a cell phone. But you can go and check it out if you have a computer. I will leave it here. I will have a link below to this map or paper also. You might want to check it out. Thanks.